called solving equations, right? And if you look at your booklet, it's not very big. It only has 4 lessons in it. So first of all, let's get your name on here, right? And the last 2 units only had four lessons in it. And they went by really quick. Polynomials part 1, polynomial part 2. This one is not quite the same. Even though it only has 4 lessons, it takes a while to get through everything. And I don't think that we'll be done before spring break. I hope we would be, but I highly doubt it. I haven't done it in the years past. Right, so usually we finish up a week or 2 after spring break, even though it's only 4 lessons. Right? It just takes a little while to go through the notes, and the assignments are a little bit harder, so it takes a little bit longer to do the assignment. So the course kind of slows down. But this is more of a feeling what grade 10 is. Like it's a continuation, right? And the stuff that we start off at the beginning is probably what students find the most difficult. So here we're solving equations. So you did this last year. We had stuff like this. 2x plus 1 equals 5, and you had to figure out what the value of x was, right? Right? And some of you guys can look at it, you can see that, right? We're just going to get into more complicated situations than what you did last year, right? But the same basic rules apply. Now, I'll tell you right off the bat, like, most students, it's kind of counterintuitive, find lessons 1 and 2 the most difficult in this unit. And you think it would get harder as the equations get more difficult, but students find lessons 3 and 4 easier to execute, right? I haven't quite come to terms of why students find lessons 1 and 2 more difficult, right? I think when you get to harder stuff at the back, you get to questions with like fractions and brackets, and you got to solve them. I think there's less choices for you to do, which makes it easier for students because it's like you got to do everything, right? And I think students find that easier. Whereas when something's only like 1 step or 2 steps, you start to make a choice. What step do I do? And that's I think where students have troubles. So I ask you to really pay attention, especially at the beginning, right? Because it seems so easy, right? But we build on things. All right, we're going to start off here. Now, these are called one-step equations, not because it only takes 1 step to get to the final answer. It's usually called 1 step because there is 1 number that you have to move or get rid of. And to move that 1 number or 1 term, it may take a couple of steps, but that's sort of what it refers to. So don't think you're doing something wrong because it's taking you multiple steps to get to the answer, even though they're called 1-step questions. Okay, now, when you have something like this without the equal sign, that is called a statement. Okay? So you're used to statements, right? So you have a statement on this side and you have a statement on this side. When as soon as you put an equal sign into there, it becomes what we call an equation. So an equation is made up of 2 parts. Those 2 parts are called statements or expressions, right? Sorry, this statement has 2 expressions. Expression here and expression there. I'm getting all mixed up. Right? Now, here's the super important part. Right? The 2 sides of the equal sign have the same value. They are equal. Okay? That's really, really important. That's all the steps that we do is based off that principle. So you may be used to, or depending on your teacher, seen an example like this. We have our expression on the left-hand side. We have our expression on the right side. You see the little scale. The scale sort of tries to symbolize like, hey, these 2 sides have the same value. They have the same weight. Even though it doesn't look like it, whatever magic number is hiding behind this x makes both of these things equal the same weight. So when we try to solve equations, what we do is we try to get rid of numbers from the side that has the variable, and the process that we do has to keep everything in balance. That's the only way. We'll talk about this in a moment here. This whole system works. So vocabulary first. X is not called a letter in math. it's called a variable, so we're going to start using proper terminologies. A variable. Okay, and now there's two different types of numbers. 2 is different than 1 and 5 in terms to what we call them.
Coefficient constant?
Yeah, 2 is attached to a variable. That is called a coefficient. All right? And a number that is not attached to a variable is called a constant. Right? All right. Then we have a left side and a right side. That's separated at the equal sign. So we have a left side, which we refer to LHS, left hand side. And we have a right side, which we refer to as RHS, right hand side. Right? And when you get to grade 11, you're going to see these a lot. We're going to do one example where we sort of talk about it and proofs. Okay. Now, the manner in which we solve equations is by doing the opposite math operations. All right? So there are 4 main math operations: adding, subtracting, multiplying, dividing. All right, so you use the word opposite, or sometimes we can use the word inverse. It means the same thing. All right? Inverse means the opposite operation. For example, if we have the word addition, that's a math operation. What's the opposite of addition? Subtraction. Right? And then therefore, if we have subtraction, the opposite is addition. Okay? And then finally, if we have multiplication, what would the opposite of multiplication be?
Divide.
Divide or division, right? Divide or division, then therefore, if we have divide, the opposite would be multiplication. And this is the way we need to be thinking about when we look in this chapter. It's always like, what's the opposite thing I need to do to get rid of a number? So it becomes easier when we start putting it in context of a question. All right. Now, looking at this, how many people know what the answer is? What's the value of x?
2.
I see here 2, 2, 2. I see lots of people. Now, if I change this from a 3 to, don't do this. If I change this to 3 to like a 5.3, do you know what the answer is? No. All right. So some of the steps that we're going to do right now seems like, why do I need to bother to do this? Right? You need to be able to do the steps for when the question becomes harder, and you can't just look at the answer. This question and this question mathematically are identical. One you can do easily in your head, the other one you can't. Right? So there's a reason why we do it. So now, symmetry is the key here. So we started with an equal sign. Here, we're going to just draw a little vertical line. Right? Whatever we do to one side, we have to do to the other to keep things balanced. And it should look the same. And when you're doing these things, and if it doesn't look the same, chances are you're making a mistake. Right? So, especially with these easy ones, one of the key things I say is, hey, find your variable. Okay, that's going to be our anchor. That's going to stay on this side. Okay, it's on the left-hand side. Sometimes it's on the right-hand side, but it's on the left-hand side. It's going to stay on that side. It's anchored right there. Everything else needs to disappear from that side. So on this side, we got a 3 floating here. Right? If you want to figure out what the value of x is, this 3 needs to go away. And so to do that, we look at what is the math operation between 3 and the variable. What is the math operation? Times. Right? So if a number is touching a letter, there's an invisible little time symbol in here, right? So then we go, okay, to get rid of it, we have to do the opposite. What's the opposite of times? Divide. So we divide this by 3. Right? And we divide this side by 3 to keep it balanced. So what we did in our first little thing here, by dividing by 3, I reduce this by a third. Well, if I reduce this by a third, all of a sudden this is not balanced anymore. We need to reduce this side by a third as well. Okay? So we go, okay, that side's reduced by a third. Now, we clean up our math. Going to our fraction unit, 3 divided by 3 cleans up to 1. So we end up with the x. And when you clean up the other side, 6 over 3, 2. 6 divided by 3 is 2. Right? Right. Now, write down the original question I changed this to. I changed this to 5.3 x is equal to 6. The method's going to be the same. Okay, we're going to anchor our variable. We're going to split it at the equal sign. Our variable's anchored right there. And we want to get rid of that 5.3 this time. Right? What's that 5.3 doing to the x? The adding, subtracting, multiplying, dividing. Multiplying, so the opposite of multiplying? Divide. So I'm going to divide. I can divide this side by 5.3. I can divide this side by 5.3. It's very symmetrical, right? Now, what's 5.3 divided by 5.3? Just x. Those disappear. That's 1. So these canceled each other out. You're left with the x. Then on the other side, 6 over 5.3. Now, here in this chapter, if you have whole numbers, that means give me your answer as a fraction. If at any point you see decimals, that means, hey, just calculate it with a calculator and the final answer as a decimal is okay. So I grab my calculator out, all right, and I go 6 divided by 5.3, and I get this decimal. I'll go 1.13. Right? So it was the exact same questions as the other one. The other one, you can look at it and say, hey, the answer is 2. But here, mentally, our brains have a hard time doing that. But the process was exactly the same. So it's really important to focus in the process at the beginning. Okay. So here we go. Next question. Split it at the equal sign, and we're going to keep things symmetrical. We anchor our variable. That's not going anywhere. But all the numbers on the same side as the variable are going to disappear. So, good. First, this 3 needs to go. How do you get rid of that 3? What is it currently doing to the x? Dividing, opposite of dividing, it's multiplying. So we're going to multiply by 3 over here. And then now we need to keep it symmetrical. And over here as well. Right? A 3 on the top cancels a 3 on the bottom. Right? So these two 3's disappear. Right? Just 3 divided by 3, 1. We're left with the x. What do we have on the other side? 18. Okay. X is equal to 18. Moving on over. Okay, we split it at the equal sign. We identify our variable. Here's the x. We're going to anchor it there. And we need to get rid of that 5. We want to do the steps. I know you can do it in your head. What is that 5 doing to the x? What's add it. So the opposite is to add. And we add this side. This is how we show our adding. At least for now. We might do a different way later on. Okay. So on the left-hand side, what happens? We have our like terms. We have a negative 5 plus 5. What do we get? 0. If it's 0, we don't need to show it. We have an x on the side. On the other side, we have 11 plus 5, which is a 16. Okay? So it seems pretty straightforward, right? But it gets a little messier. Even these little steps, just the way the numbers are. For example, this one over here. All right? Nick, you okay?
Yeah.
All right. We go over here. We anchor our x. So that 3 on the same side needs to go. What's that 3 doing to the x? Timesing. All right? So the opposite timesing is to divide. So we divide to get rid of it. But we need to make the other side look the same. We need to divide it by 3. And this is where students sometimes have troubles here. It's like, Mr. Dhaliwal, there's already a 3 sitting there. Like, where do I put this 3? Right? It can go just off to the side. And you can just call it 1 over 3. Because dividing by 3 means the same thing as multiplying by a third. Is that okay? And if you wanted to look 100% alike, instead of going dividing by 3 on this side, you can just change that to multiplying by a third if you want, right? So it looks identical, right? So students often make a mistake here. It's like, oh, there's already something on the bottom. Where do I put this extra 3? Just put it off to the side. right? Now, who's seen this stuff before? This should be all, just only not too many hands. Okay. So now 3 over 3, cancel each other out, makes 1. And what do we have on the other side? 2 over 9. So you got to remember our multiplying rules with fractions. So to multiply with fractions, we multiply the tops together. 2 times 1 is 2. 3 times 3 is 9. So our answer is 2 over 9. And that, I'd be impressed if some of you guys could tell just by looking at it. Okay. So now, this question asks us the question to solve it. That's what we did here. X is 2 over 9. But also to verify. Verify means to check your answer. Make sure it's right. Okay? So, Johnny, what are you doing? Okay? So how do we verify? How do you check if an answer is right? Answer is correct if your left side equals your right side. Okay? So you have to prove that your left side is equal to your right side. How do you do that? You start off with the side with your variable, and you write it up. So that, in this example, is the left side. So I'm going to start off with writing down my left-hand side, and we had 3x sitting there. Now, if we can prove it equals 2/3, then we've done our job correctly. So what we do is we take our answer, and we replace the x with its value. So we came up with the answer of 2 over 9. Right? So where we see x, we're going to put 2 over 9 in. And we do that with brackets to help preserve the arithmetic that's going on here. Okay. And now we have 3 times this fraction. We're good there, Blake? Yeah? Now if it helps, we can make this over 1. Okay? And what do we get if we do this calculation? 6 over 9. 3 times 2 on the top is 6. 1 times 9 is 9. So it doesn't equal the other side yet. Because we can simplify this fraction, can't we?
Yeah,
Divide by 3 on the top and bottom. Divide by 3 here. Divide by 3 here. Oh, disappear, please. So 6 divided by 3 is 2. 9 divided by 3 is 3. So we get 2 over 3, which equals the other side, which equals the right-hand side. So that's how you can check if an answer is right. So technically, every single question, just about in this chapter, you can tell if your answer is right or wrong by going through this process. You come up with a number. I think the x is 5.2. You plug it back in. If it equals the other side, you've done it right. Right? So if you want to put the time in, you can make sure you get 100%. That'll be not many chapters you can do that with. All right. So let's go into the back side here. All right. Okay. So I'm going to bounce around here. Let's see, which one do I want to do? All right. Okay. I'll do a few here. I'll do one, then I'll get to you guys to start doing some of these. All right. We'll start off with this one here. We're going to split it at the equal sign. We're going to anchor the variable. Now that we have that 4 sitting there. Okay. What's that 4 doing to the x? That's the question that should be going through your mind. You're adding, subtracting, multiplying, or dividing. Multiplying is the opposite of multiplying. Is to divide. That's how we get rid of it. So we divide. And whatever we do to one side, the other side's got to look the same. So I'm going to divide here. And I'm going to divide here. Now, there's already a 3 sitting at the bottom. So I'm just going to put it off to the side and throw a little 1 up here. and we'll dot. Okay? So now, we're going to clean this up. The 4's disappear. And we have x over here. And what do we have on the other side?
Wow.
Hmm?
10 over 12.
10 over 12. And don't forget about the negative sign, 10 over 12. Now, whenever you have a fraction, you need to check if you can clean it up.
-5 over 6.
Good. We can divide by 2. Divide by 2, so it's -5 over 6. Now, I think most people will probably go through here, especially if you're feeling like this is a lot right now. But if this is easy, remember our rationals unit. When we got to this stage here, we said we could simplify first. You can still do that here. Look at this 10 and the 4 here. They both, 2 can fit into both of them. So we could have divided by 2 here and 2 here. That would have been a 5 and a 2. And then we multiply the tops together. 5 times 1 is 5. 3 times 2 is 6. And it gets you straight to the answer. Right, so now this depends on your comfort level in math, right? This is more procedural. If you, okay, I multiply the tops and I look at the answer at the bottom, simplify, go for it. If you find this really comfortable, I'm going to urge you to start looking at questions like this and simplifying it at this stage. Because that's the scale that will help you more in grade 10 and in grade 11, okay? But right now you're learning about solving equations and we're bringing the stuff from back in November, right? It might be a lot for somebody. So all depends on where you are. Okay, so now let's have you try this question. Okay, we're going to split. Yeah, all right, split it here, anchor the x, get rid of that 2.3. Don't go ahead. All right, I know you're eager and you're understanding it. It's great, but there's little things I want to catch because I went around right now and I saw like 8 people with the right answer, but the math that they showed on the page was incorrect. So I saw a lot of people saying, hey, I need to get rid of that 2.3, so I got to multiply by 2.3. So lots of people did this, right, which is great to see. And then, but over here, they did 2.3, like this. And mentally in your brain, you're doing the correct thing. What you're displaying on paper is incorrect. Because we're not multiplying the denominator by 2.3, right? Because that's what this is saying, right? This is saying, and let me grab my calculator here. Oops, do you got my recorder going? Yes, I do. This is saying we're going 2.3 times 2.3 on the bottom. We get 5.29 on the bottom. You didn't get rid of it. You just made the number bigger. What you're meaning to write down is 2.3 up here. The top got multiplied by 2.3 here. The top got multiplied by 2.3. And what this is saying is 2.3 divided by 2.3, which equals 1, which makes it disappear. So that location of that 2.3 that you write down is important, right? So now these cancel out. So I know you want to target that 2.3. You're targeting the right number, but you got to put your calculation in the right spot. So x equals 7.4 times 2.3. What number it is? 70 point something, right?
17.02. Yeah.
02. Thank you. Okay. So I know some of you guys find this easy, and you're getting the right answers, but your communication needs work as well. Right, so let's try this one here. Then I'll try a harder one, and we'll stop for the day. Okay, do this one.
Already did that.
All right, we'll see. Make sure your syntax looks nice, because I had to talk to you about your syntax on this one too. All right, we anchor it. You want to get rid of that number.
The word, I think it's where you put the
I'm glad most people have gotten this one. All right. The one error that I saw is I saw a lot of people going like this. If you do this, what you get is the 4.5s cancel out, but you have negative x is equal to whatever the number is on the right-hand side. Right? Because you didn't cancel out the negative sign. So if this is actually negative 4.5, so you need to divide by the negative 4.5. So this ends up being just an x sitting here. And a negative 4.5 on this side, right? So that's really important there. So then we take it, what number do you get? I think it's like 0.3.
Negative 0.3.
Negative 0.3, okay. All right, last question. Then I'll have you staple your sheets together, and then we'll call it a day.
X equals.
This one here. Okay, so before we progress, this question is not quite like the others. It's a bit different. Do you guys spot a difference between this question and the other one? The x is on the bottom, right? When we're solving, we want our final answer to be x equals something. And we can't do that if the x is in the bottom, right? Because if you have the x on the bottom, your final answer will be like 1 over x equals something, right? We want x equal to something. So what we need to do is get rid of the x off the bottom. Just the same way we did by get rid of, oh, I didn't do that one. We got rid of, oops, over here. Yeah, let's go maybe here. Here. We didn't want this 3. This 3 was on the bottom. We did the opposite. It was dividing the top number, so the opposite was to multiply. So we're going to do the same thing here. It's like, hey, we don't like the location of this x. So we're just going to get rid of it. So the x is dividing. This is what we want to get rid of. The opposite of dividing is to multiply. So I'm going to multiply this by x. And I'm going to multiply this side by x because I want to keep it symmetrical. Okay? Now, just like before, once we've done that, we clean it up. X on the top will cancel an x on the bottom because x divided by x is 1. Or do you remember from our last unit, 1 exponent and a 1 exponent in the bottom, 1 minus 1 is 0. That cancels each other out. It's all interconnected here. So now we clean this up. On the left side, we have just a 2 sitting there. On the right-hand side, we have a 4x over 5. Okay. Now, the x has moved from the left side but to the right side. That's fine, but it's on the top. That's where we want it to be. So now, it's in the location where we want it to be, so that's where we're going to anchor it. We're going to anchor that x on that same side. 4 and 5 need to go. So, two numbers to get rid of, right? Doesn't matter which one you pick first. I like usually doing the denominator first. So, to get rid of the 5, what is that 5 doing to the x? Dividing, the opposite of dividing, multiply. So we multiply by 5. And we multiply by 5. And the 5s disappear. And we're left with a 4x over here. And over here, 5 times 2 is a 10. Okay? Then we want to get rid of that 4, right? That's the next thing. So what is the 4 doing to the x? Multiplying, so opposite of multiplying. Divide, so we divide by 4. We divide by 4. The 4s cancel each other out. That's with the x, and we have a 10 over 4 sitting here, which we can simplify that fraction. To what, Johnny? No. Not as a decimal, but as a fraction.
It has to be a fraction.
Yeah, we're going to keep it. So what number can both fit into 10 and 4?
2.
2. Divide top and bottom by 2. So 5, 2. Okay, now, this is the basic way to go through this question. Now, you can think of this question slightly differently. So I'm going to rewrite this question just off to the side here at this stage here. So I want you to write this down as well. 2 is equal to 4x over 5. Now, instead of thinking of as 4 and 5 as two different numbers being applied to x, think of it as this one number being applied to x. Think of it as the fraction 4 over 5. Right? So instead of getting rid of the 4 and getting rid of the 5, let's just get rid of the fraction 4 over 5. What do we want to do? We want the 4 to disappear. We want the 5 to disappear. Well, to get rid of the 5, we need to put a 5 on the top. To get rid of the 4, we need to put a 4 on the bottom. Right? Because that's how we get cancel multiplying, dividing things. A 4 on the top cancels the 4 on the bottom. 5 on the top cancels the 5 on the bottom. Does that make sense? And we're going to do the same thing to the other side. Right? So if we do that to one side, we have to do it to the other. Okay? So the 5s cancel out, the 4s cancel out. And if you do this calculation in your head, you got 10 over 4. Right? I can go like this. That helps. 10 over 4, same answer. Right? And you can simplify that to 5 over 2. Or, see, I'm saying a lot of stuff here. You pick the path that works easy in your mind. At this stage, you could have done fraction simplifying as well. You know, of a number on the top and a number on the bottom, they could both been divided by 2. You could have done this divided by 2, this divided by 2, 1 over 2, 5 over 2. You see how everything is built up in this course. And some people will be able to do some of these calculations like in one step, truly in one step. Some people may need to do it in 3 steps to get the answer. And it's fine. Mathematically, as long as each step you do is correct, I don't care which procedure you take. Okay? So I'm going to stop there. I'm going to hand back